Hello and welcome to another Physical Sciences 3 lecture. We're looking at electrical resistance in this lecture, and resistance has the conveniently chosen symbol of R. If current passes easily through an object, the object has low resistance. So for example, metals have low resistance. And if the current does not pass easily, the object has high resistance. Example, something like rubber, and we call that an insulator, a rubber, which is mentioned lower down the page. So a resistance depends on what the object is made of and its shape and size. It is convenient to think of resistance as an opposition to current flow. The resistance is measured in ohms, so that's the units for it, and it has this Greek letter omega for the symbol. So it's the Greek letter omega. It's a Greek letter. Okay, so the letter R is occasionally used in place of the omega symbol, especially in electronics. So sometimes, and we've got an example where we have that, we say that the resistance is something R, but it means ohms as well. A component made specifically for its resistance is called a resistor. Okay, the resistor has two symbols, which we've already seen earlier in this course. This one and that one. So it's like a rectangle and a zigzag. The rectangle is the UK variant, and the zigzag is the American or US version. So an insulator is um, a non-conducting material. It has high resistance. Okay, insulators, high resistance. Good. Now we have this very useful law called Ohm's law, and it's V equals I times R. So it's the voltage is equal to the amount of amps times the resistance. Now I've got this triangle here which helps some people um, if you're not very confident with your rearranging of maths, then you can use this triangle here and you cover up the one that you want to find. So if you want to know what the voltage is and you know what the currents and the resistance are, you can cover up the V, and V is equal to I times R. So if we go back, oops, ooh, okay, and if we want to find out what I is equal to, we cover that up, and I equals V divided by R, like that. So V over R. And the last one is, if we go back again, cover up R, we want to know what R is. R equals V over I. Okay, so that triangle does help some people, so that's what that's there for. Feel free to use it if it helps. Good. Okay, so we have a few examples now. So our first example is we have a 0.6 amp current flows through an electrical component which has a 12-volt potential difference across it. What is the resistance of the component? So we start off with V equals IR, and so let's rearrange that. So R is equal to V over I, and then that's equal to 12 over 0.60, which is equal to, let's get my calculator going again, 12 divided by 0.6 is equal to 20. 20 ohms. Okay, 20 ohms. Now here in the next example, example 8, we have 100 ohms. So that R this time is standing for ohms, because I didn't want to write the omega. 100 ohm resistor has a potential difference of 12 volts across it. What current will flow through the resistor? So again, our usual Ohm's law is V equals IR. So I equals V divided by R, which is going to be equal to 12 volts again, divided by 100. And that's equal to 0.12 amps. Okay, and quite often we like to write amps as milliamps, so that would be equal to 120 milliamps. You might see that quite a bit. That's probably more of an electrical thing. 0.12 amps is the SI unit. Okay. And speak of the devil. So 15 milliamp flows through a 10k ohm resistor. Find the potential difference across the resistor. Okay, so good. Potential difference, PD is equal to V. Okay, V equals IR, which is equal to 15 times 10 to the negative 3. So milli means 10 to the negative 3, just like it always does. 10 kilo is 10 to the 3. Okay, so this is like 10,000 or 10 to the 3. 10 times 10 to the 3, I should say, and this is 15 times 10 to the negative 3. And because if you times them together, then 10 to the negative 3 cancels out with 10 to the 3, so you end up with just equals to 15 times 10, which is equal to 150 volts. Okay, great. We'll leave those ones there.